So example 6, find all zeros of the polynomial function or solve the given polynomial equation. Use the rational zero theorem, Descartes' rule of signs, and possibly the graph of the polynomial function shown by a graphing utility as an aid in obtaining the first zero or the first root. Okay? So let me just make a little clarification on the Descartes rule of signs, and we'll do an example. Now, this rule, assuming that you don't have a graph to look at, Descartes' rule of signs is a useful help for finding the zeros of a polynomial. Descartes' rule of signs will not tell you where the polynomial zeros are. You will need to use the rational zero test, the theorem, and synthetic division. But the rule will tell you how many roots you can expect. Okay, so I gave you two ways. You can use Descartes' rules of signs, or we can just look at that polynomial function and determine. Okay, so let's do one more example. We have here x cubed minus 2x squared minus 9x plus 18 is equal to 0. Let's look for all the possible rational zeros. So we're looking at the constant term. So we have here plus or minus 1, plus or minus 2, the constant term, which is 18 here, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, all over the leading coefficient, plus or minus 1. So our possible zeros we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. So let's find the first zero or the first root. But we're going to just find all of the roots. Okay, so starting with 1, using the synthetic division, we have coefficients of 1, negative 2, negative 9, and 18. Here we go, bring down the 1. 1 times 1 is 1, added to negative 2, we have negative 1. Negative 1 times 1, we have negative 1, added to negative 9, we have negative 10. Negative 10 times 1, we have negative 10, added to 18, we have 8. This leaves us with a remainder, so 1 is not a possible zero, not an actual zero. Let's try negative 1. Negative 1, we have, here again, coefficients 1, 2, negative 9, and that is negative 2, and we have 18. Okay, bring down the 1. 1 times negative 1, we have negative 1. And then add that to negative 2, we have negative 3. Negative 3 times negative 1, we have 3. Add that to negative 9, we have negative 6. Negative 6 times negative 1, we have 6. Add that to 18, we have 24. We still have a remainder, so negative 1 is not an actual zero. Number 2, we have here again, not number 2, but let's test 2. We have 1, negative 2, negative 9, and 18 again. Bring down the 1. 1 times 2, we have 2. Add 2 to negative 2, we have 0. 0 times 2, we have 0. Add that to negative 9, we have negative 9. Negative 9 times 2, that gives us negative 18. Add that to 18, we have 0. Therefore, 2 is our actual zero. Okay? So we're going to find the other the other actual zeros. So we're going to set up our factors. We have here x minus 2 times, here we go, x squared minus 9. Hello. X minus 2 times, let's repeat that again, x squared minus 9 equals to 0. Jeez. Okay. All right. Factor x squared minus 9. and we have x plus 3, x minus 3. Set each of those factors equal to 0, so our solutions are 2, negative 3, and we have positive 3. There we go.